let's try an example of our kind of one-dimensional funny chain rule. So I want to find df dt for f of x and y is x sine y, and x is t squared and y is 2t plus 1. So there are two ways you could do this, right? One that should present itself obviously to the lot of you guys is what?
Treat one like a constant and then do the chain just with the x.
Nah, forget that crap.
No?
What was the other?
Substitute.
Yeah, substitute the t's in for the x and y, right? And then take the derivative of that thing. You see that? That would certainly work, right?
Be gross.
Yeah, it would be kind of nasty,
Product.
but it would definitely work. I'd have to use the product rule, whatever. Let's try it the other way because we just learned this new trick. Right, so I want to think the FDT should be what?
df with respect to x
Okay,
plus
plus
the partial derivative of f with respect to y dy dt.
okay, all right. So df dt should be, okay, what's the partial of f with respect to x? Sine of y times the derivative of x with respect to t is 2t plus,
Yeah.
you guys all see that? X cosine y times
Minus
2. Okay, but that feels really dorky, right?
2. Well, if you put in all the t's for the other step, then you'll only have t's.
Yeah, it feels like maybe I should answer this in t's, right? So I'd have sine of
2t plus 1
2t plus 1 times 2t plus,
t squared cosine 2t plus 1 times 2.
perfect.
So we're treating this the y's and x's like the substitutions that they are.
Yeah, exactly. Yeah, you're going to end up doing the substitution that you would have done anyway. You guys see that? This thing even looks a little bit like the product rule, right?
There's a reason for that.
Is this in any way related to parametric?
Yeah, in
Stuff?
fact, that's exactly what we've done here.
Yeah.
We made a parametric curve, right?
Yeah.
You guys all see that? And then I took a derivative of it. So, what's this thing telling you? This thing's telling you how steeply this thing's going up at a time t. Does that tell you all the information you want to know?
No.
Maybe not. We could ask about a t-value, right? But this tells us how fast is the height increasing for an increase in t.
Is there some explanation of how that algebraically simplifies to df over dt?
This thing?
Yeah, so like, could you cancel out the dx over the partial x, and then...
You could think this way. However, I must warn you about thinking this way. These things are not fractions.
Right.
In Calc 1, they look like fractions, they work like fractions, there's no problems, right? But
Right.
here, I really would like to say maybe I could cancel these things, right?
They're not the same.
They're
They're-
definitely not the
They're
same,
not the same,
right?
but they have some sort of relationship.
And they do have a relationship, right? Which is given by the chain rule. If you want to think about canceling them, right? Like, if you thought about canceling both of these pieces, what would you think you would get?
Oh, you'd get the partial f over dt when you add it together.
Uh-huh, so you'd get two of them, right?
Right. And two partials make a whole if you have two components.
So you'd get
Yeah, but
two
isn't it only partial from
partial of f dt,
and,
right?
And then a
kind of.
from t.
And then I would maybe
Right, but
think
to keep the
two
denominator the
partials make
same.
a whole,
Yeah.
but it depends on what dimension you're in.
Yeah.
Right. So if you had a three-dimensional, or a four-dimensional, I mean, then three partials would make a whole,
Yeah.
and then
Yeah, the number of input variables is how many you need to make a
Right.
kind of a whole, right? I worry about this, but I'll let you think that way.
Okay.
We'll revisit
It's
it.
very,
later.
very loose, kind of.
But it makes
It's
Yeah,
okay to
it's
think
not
about
a
this.
terrible idea in that it will keep you from doing the dumb thing,
Uh-huh.
which is just saying, okay, I'm just going to take a partial with respect to one of the variables and then d that variable with respect to time and forget that other piece, right?
Uh-huh.
Like, as long as you're thinking this way, you might remember there should be another half of that thing.
Mm-hmm.
And that kind of thinking I would encourage. Cool?
Does that have any real meaning, though? A partial f over dt?
Oh, no, that's, yeah,
No meaning at all.
no.
Okay.
Hence the thought bubbles.
Yeah, hence the thought bubbles and me saying don't think this way, but you could think this way.
Okay.
I really want to hedge my bets with this thing because it's not actually the way it works.